What is mountaintop removal and MTVF? MTVF stands for Mountaintop Mining Valley Fill Operations. So just to give you a little background on why this is happening is it's in order to get coal. And so coal primarily consists of densely packed organic carbon, which produces a massive amount of energy. So in order to get this coal, mining companies remove the top of mountain summits and their ridges to extract the embedded coal. And in order to access the shallow coal seams, they clear existing forests and then remove the topsoil and then use a combination of explosives and heavy machinery to loosen and remove the dirt and rock material that covers the coal seams. And then mechanized drag lines are then used to remove rubble and to clear access to the exposed coal seams on the rock face. And some things to regulate this process. There were federal laws that were established, and organizations that are in charge of the regulation are the EPA and ACOE.
As coal mining has progressed in the Appalachian region of the United States, the effects of top mining value fill, also known as MTVF, can be seen throughout the region as the progression of mountaintop mining occurs, specifically in coal mining. The negative impacts that are caused by MTVF inherently translate to the ecosystems of the Appalachian region. The aspects that are affected are the destruction of headwaters and soil infiltration, which lead to major problems relating to the ecosystem. With the destruction of headwaters, the areas in which some animals such as invertebrates like isopods and vertebrates like salamanders can habitat and reproduce properly is becoming very limited. This in turn leads to an imbalance in the ecosystems that before MTVF was very well set. Also, MTVF is causing destruction of soil in the region due to the nature of the explosives and chemicals used in and released during coal mining. Ultimately, MTVF has led and continues to lead in the destruction of ecosystems in which animals of the Appalachian region once used to thrive.
The local environment has also suffered greatly due to the impact of this mountaintop removal. It has led to a lot of change in the land, covering over 1.1 million hectares of forest, which is equivalent to about 4,500 square miles. So a lot of area has been destroyed directly due to this form of mining, as well as 2 kilometers of covered rivers, which has led to changes in ecosystems from microorganisms all the way up to large fish that was traditionally part of like Appalachian meals. It's also destroyed the hydrology in the region. Water cannot be properly absorbed by the ground, leading to stunted tree growth and other environmental issues that are a direct result of this mining in this area. On top of local impacts, there are also many far-reaching environmental impacts of mountaintop removal and MTVF. One thing that's particularly concerning are the chemical changes in the water, because there's currently no way known to reverse the damage done by this mining. More ionic compounds and acids are present in the water than there's ever been, and this has disrupted the aquatic life in those ecosystems, not only in the areas of Appalachia, but also the areas that the rivers are interconnected with. This is because of the ionic compounds that have killed many microorganisms that provided a crucial role in the larger scheme of the ecosystems they were a part of. This infograph provides a great visual for the amount of species that are at risk due to the hydrology that has been destroyed due to mining. You can see in those areas of Appalachia, there's upwards of 50 species at risk due to this watershed.
As for what is being done to lessen the impacts of MTVF, there is legislation to hold people accountable, and there are active restoration and enhancement efforts for degraded streams, as well as projects for stream creation and man-made valleys. Section 404 of the Clean Water Act helps regulate materials and actions that are at risk of negatively impacting U.S. waters. If negative actions happen, the applicants are held responsible to fix it. The Surface Mining Control and Reclamation Act is a second piece of legislation that states that altered or destroyed water sources must be restored to a state that is similar to what the source looked like prior to destruction. There are limitations to these efforts, though. Man-made valleys are much flatter than natural valleys and often resemble grasslands. Stream creation focuses more on structure of the stream rather than if that stream is functioning the way natural streams before it did. And these plans do not measure ecological function, which is an important aspect of a stream.
What we can conclude about mountaintop removal is that it's not good for the environment or economically. It ruins habitats and ecosystems, causing species and organisms to not have homes anymore. And it does more harm to the environment than good. It worsens climate change, and it pushes species out to possible local extinction. When they do go back to try and fix land that is destroyed when they go for lower streams, they end up having to pump a lot of money back in to fix it. And when they do that, a lot of the time the functionality of the land is not good anymore, and it's not good habitat for the species that need it.
The first thing that can be done to improve the current deficiencies in reclamation mitigation is to put in place a method for direct measurement for ecological functions. This can be done through the measurement of primary production and nutrient uptake. There are many scientific studies available on how to measure the ecological functions of streams and rivers. The second thing is a more thorough study of the specific processes and history of the river when natural channel design is utilized. The NDC approach focuses on structure, not function, instead of focusing on the shape of the replacement channel. The ability to transport sediment and how it supports living organisms needs to be studied. The third thing is better understanding of biophysical factors such as sunlight, vegetation, and organic matter inputs. Through study of the ground matter surrounding the original and replacement channels needs to be conducted. Measurement of trace chemicals in water alkaline levels should be conducted. The fourth thing is to avoid the temptation of creating perennial streams in place of intermittent headwater streams. Since the ecosystem of an intermittent headwater stream is much different from a perennial stream, a thorough study of the intermittent headwater habitat utilized by insects and animals needs to be understood. Measurement of the ratio of algae in each type of channel can also help to understand the effects on the river's ecosystem.